Hello, Mindsetters, and welcome to this is another great edition of your Learn Extra Live with me, Abram, and I'm not alone. I'm with Lizzo. How are you, Lizzo?
I'm absolutely fine, thank you.
A moment that we've all been waiting for. And guess what? It's just a new month. It's June. So welcome to the 6th month of the year.
We're almost halfway through the year.
Yeah.
Hopefully you guys have done a lot of maths and you're ready to do a lot more.
Hence, we're doing a revision today. But what's the topic?
Well, what we're going to be doing today is we're going to revise everything that you should know from grade 10 trigonometry. Now, guys, trigonometry is something that you meet for the first time in grade 10, so very often it can seem very daunting, but if you learn the basics very well, remember a lot of it gets repeated in 11 and in 12, so it does get easier, but only if you get the basics under control.
I like that. And as much as so many Mindsetters are writing their exams, we just want to wish them a great and all the best, guys. Make sure that you study hard and use this opportunity. That's what we're saying. Lizzo, take your position. Right, Mindsetters, I've got 3 things to say. Firstly is that today it is our Triple M, which means Mindsetters Maths Monday. Yes, you've guessed it right again. And the second last 3 things that I need to tell you is, 1, you can join us on Facebook to chat with us, engage with us, ask any question that you might be having. Our Facebook link is so simple. It is facebook.com/learnextra. And secondly, you can also tweet us, follow us at LearnExtra. And lastly, you can just download the notes for today's show on learnextra.co.za/live. And let's get ready to learn a lot because it is our Triple M Mindsetters Maths Monday. Lizzo, take it.
Right, so guys, what we're going to do first is just have a look quickly at some of the absolute basics that you have to have under control before you can start attempting the different types of questions. So really, we're looking at the skills that you guys need to be comfortable with in order to deal with trigonometry. Now, the first thing that we need to have a look at is our different sides of our triangle. The adjacent, the opposite, and the hypotenuse. Now, the hypotenuse is the easy one. It never changes. The hypotenuse is always across from my 90-degree angle, right? It is also the longest side in my triangle, and the hypotenuse we often abbreviate using the symbol R. Now, your adjacent and your opposite are interchangeable depending on your position. So you first have to establish which angle am I working from. Now, in this case, what I've done is I've put the sine theta over here at C, and if you get confused, draw yourself a little man at C. That is now your vantage point. So if you are standing at C, the side directly across from you will be your opposite side, also called Y, and the side right next to you will be your adjacent side, which is X. Now, guys, the opposite and the adjacent story is very, very important. Just have a look here quickly. If I were to move my little trig man over here, now he's purple and he's standing at angle B. My hypotenuse will not change because it's still the side across from the 90-degree angle. However, my adjacent and my hypotenuse swap around. So now, what was before adjacent will now be opposite, and what was before opposite will now be adjacent. Guys, that is very, very important. You have to establish where you are. Right. Another thing that you cannot do trigonometry without is without knowing the different trig ratios. So we're going to write them down. You need to commit these to memory, but I have to promise you that the older you get, the better you'll know them because you'll use them all the time. So let's have a look here at sine theta. Sine of theta is opposite over hypotenuse, but we use the shorthand y over r. So sine of theta is y over r. Then the cos of theta, remember this is a ratio for the lengths of the sides, is x over r. In other words, adjacent over hypotenuse. And there's lots of silly little rhymes that you guys use to remember these. Finally, tan of theta is y over x. But boys and girls, of late, the reciprocal functions, the reciprocal ratios have also come back into the syllabus. So you need to know that the reciprocal of sine is cosec, and cosec is then literally just y over r flipped on its head, so that will be r over y. Similarly, we have sec, which is the reciprocal of cos, that's r over x. And finally, cot, which goes with tan, and that is x over y. Right, so this is a bit of knowledge, boys and girls, you cannot do without. You absolutely have to know it. Make up a rhyme for yourself, sit with your friends, make sure that you know these things. Now, I'm going to skip through our trig graphs for now, and I'm quickly going to go to these two triangles over here, which are our special angle triangles. Now, boys and girls, we all know you guys have the Casio calculators, which can calculate the special angles for you. Back when dinosaurs still roamed the earth and I was at school, our calculators weren't able to do that, so we had to come up with another way to do the special angles. Now, this is a very important life skill, even if you don't use it when you're under pressure in an exam. Often when you write university entrance exams and even university exams, calculators are not allowed, unlike at school. So, our special angles are the angles 45, 30, and 60. Now have a look at this special angle triangle over here, the first one, which I used to calculate 30 and 60. I'll show you a quick way to remember how to draw it. What I do is I draw an equilateral triangle, so therefore all the sides, and I decide that all the sides are going to be 2 units long. Then I say, well, hang on a second, if it's an equilateral triangle, all the angles must be 60. So this one is 60, this one is 60, and that one is 60. Then I use a little skill called dropping a perpendicular. And because this is an equilateral triangle, what happens is the bottom side gets halved to 1 and 1, and my top angle over there gets halved to 30 and 30. So how would you use that? Well, I think we better have a look at the pretty one that was drawn for me before. Let's say you are asked to calculate, without the use of a calculator, the sine of 30. You will place yourself over there at the 30-degree angle, because remember, it's very, very important that we know where we are placed. And then you'll say, right, I want the sine of 30, but I know that sine is opposite over hypotenuse. Now, if I look here at 30, opposite to me is 1, and the hypotenuse is 2. So I can calculate, for instance, that the sine of 30 is a half without using a calculator. Moving on to the triangle that we use for the 45s, what I do here is I draw a right-angled isosceles triangle. I say that's 90, that's 1, and that's 1. This side over here, root 2, can be calculated using Pythagoras, the same way the root 3 over here is calculated using Pythagoras. Now let's say I want to calculate the sine of 45. Then I'll say, okay, I place myself over there at 45, and I say the sine of 45 will be the opposite side, which is 1, over the hypotenuse, which is root 2. So the sine of 45 is 1 over root 2. But now I want to show you guys something interesting. If you put sine 45 into your calculator, you get an answer that looks a little bit different. And my students always like to tell me that I'm wrong, that I made a mistake. If you put sine 45 into your calculator, you get root 2 over 2. Now guys, root 2 over 2 and 1 over root 2 are absolutely equivalent. They mean exactly the same thing. Your calculator is just so clever that it does something called rationalizing the denominator. So what your calculator is secretly doing, while you're not even thinking about it, is your calculator is multiplying by root 2 over root 2. Now surely that is allowed, because as long as the numerator and the denominator are the same, I'm just multiplying by 1, so I'm not changing anything. And that's how your calculator gets to root 2 over 2. And in this way, I don't have a square root in the denominator, and this is called rationalizing the denominator. Right. So guys, that's your special angles. Now, let's go back quickly to your trig graphs and what you need to know about your trig graphs. Now guys, if you're having a hard time remembering what the trig graphs look like, you can use the table function on your calculator. The first graph that I've got over here is the graph y is equal to cos x. Now, I always say to my students, even if I wake you up in the middle of the night and I say y is equal to cos x, you have to take a pen or pencil and quickly scribble this curve for me. At 0, the y value is 1. At x equal to 90, the y value is 0. At x equal to 180, the y value is 180. 0 again at 270, and 1 again at 360. Now, this is our very basic cos graph. I'm going to show you a little bit later on that we can do all sorts of things to make it more complicated. But it's important to know that for our basic cos graph, its period is 360 degrees. That means it takes 360 degrees on the x-axis before it's finished its little cos squiggle, and thereafter it's going to start the same wave all over again. Something else that's important to know is that its amplitude is 1. Now, the amplitude is defined as the maximum that the graph is ever displaced from the position of rest. Now, your position of rest is in the middle of the graph, so the highest that you go to is 1. Right? We can mess with the amplitude, but for your basic graph, y is equal to cos x, period 360, and amplitude 1. Now, the cos and the sine graph are quite similar. If you go y is equal to sine x, here's my sine graph, you will see that these two graphs are basically 90 degrees out of phase. So, where x is 0, y is 0. Where x is 90, y is 1. Where x is 180, y is 0, and so forth. But the properties are very similar. Both of these graphs have a period of 360 degrees. So that means after 360 degrees, it's just going to start the same old squiggle all over again. Also, the amplitude of the sine graph, its maximum displacement from position of rest is 1. Now, the tan graph is a bit of a different customer. It looks a lot different than the sine and the cos graph. The tan graph, firstly, has a period of 180 degrees. That means that it takes only 180 degrees before the tan graph finishes its shape. So have a look. It goes up, then it goes down, and after 180 degrees, all it does is it repeats the same shape again. So we can say that its period is 180 degrees. The other thing that the tan graph has that we don't have with the sine and the cos graph is at 90 degrees, it has an asymptote. Now, guys, if you were to type into your calculator tan 90, let's do that quickly. It gives you maths error. Now, that doesn't mean that your calculator is broken. It means that at 90, tan does not exist. The graph gets impossibly steep. It gets closer and closer and closer and closer to 90, but it never gets to 90. Right. So that's very, very important. Also, as far as the amplitude is concerned, the amplitude is infinite. I cannot say it goes up to 2,796. I don't know. It goes up and up and up and up infinitely. So that's very important. Another point that's very important on our tan graph is this point over here. Where x is 45, y is 1. Now, that was bad sketching on my behalf. I should have started at the 1. So, at x 45, y is equal to 1. Now, guys, these basic properties about the basic sine, cos, and tan graph, you have to know, because it's only then that you will be able to figure out all of the changes, some of which we're going to be discussing after this break.
Thank you very much.
Over to you.
Thank you very much, Lizelle. Mindsetters, now I have some great news for you. You've been hearing us talking about this new movie that is coming on the 7th of June, which is called After Earth. Now you can have an opportunity for you and your friend to come watch out this movie. All you need to do is to hear the keyword that I'm going to be giving you. I'll also post it on Facebook, and then after, you can just get into learnextra.co.za/After Earth and enter for the competition. After this, we'll play you a trailer, and then after the trailer, we'll make sure that we announce last week's winners on Thursday. And also, who knows, you could be next. So take a look at this trailer and let us know what do you think and enter for the competition, because this is a must-watch movie. See you after this. Right, welcome back, Mindsetters. It is still our Triple M Day, which is Mindsetters Math Monday. And now it is time for me to give out a winner. After seeing that trailer, it's a must. I just can't wait for the 7th. I'm going to be there, so make sure that you're also there. The winner from last week's show on Thursday is Tabang Mutlo. So yeah, congratulations. Hope to see you there, and we'll be giving you more details on your email on how you're going to get your tickets. Tabang Mutlo, well done to you. Now, if you'd like to enter for today's show, all you need to do is hear this keyword and post it and type it on our entry form. The keyword for today's show is calculate. Calculate, as in like calculate. Yeah, Lizelle has given you so many clues earlier on about calculators, the modern days and nowadays. But then your keyword is calculate. Make sure that you go over Facebook. Our Facebook link is facebook.com/learnextra, and that's where you'll get your link to your entry form, or you can just simply go to learnextra.co.za/After Earth. This is a movie that we all must see. Lizelle, see you there.
Okay. All right, guys, so now that we've discussed what a basic sine, cos, and tan graph look like, we have to have a look at what we can do to change the graphs up a little bit. So in grade 10, you learn about y is equal to a cos x plus q. Now, a is whatever stands in front of my sine, cos, or tan. And a controls the amplitude. Right? Remember, we spoke about the amplitude before. We said that the amplitude is the maximum displacement from the position of rest. Then we have Q, and Q controls the vertical shift. So Q Up to now, there's been no vertical shift, so Q in all of our 3 graphs that we've looked at was 1. Sorry, was 0. And there's been no strange amplitude. All of the amplitudes in the graphs that we've been having a look at was 1. So A controls the amplitude, and Q controls the vertical shift. Let me show you guys an example. If I were to say to you, y is equal to 2 sine x, you now need to be clued up enough to know that that 2 means that my amplitude of my graph has changed from 1 to 2. So just to do a rough little jiggle, my sine graph will still have the same period. It will finish at 360 degrees, but its maximum value will be 2, and its minimum value will be -2. So its maximum displacement from position of rest is 2. All right, so that would be the effect of the A, the number in front of my sine, cos, and tan. So guys, if A gets bigger, what's going to happen is my graph is going to get steeper. And if A gets smaller, what's going to happen is my graph is going to get flatter. Now I'm going to try and show that to you guys over here. Now what I've got drawn in red here is a normal sine graph. Y is equal to sine x. All right, so that's the one that we spoke about earlier. Now here I've got a cute little button that I can use to change the value of A. So let's do this. I've made the value of A 3. So now let's have a look. There's my old sine graph. It's still in white. But what has happened the moment I made A, that's the number in front of the sine, 3, my graph's amplitude has increased to 3. Pretty clever. I can make A smaller. Let's make A 0,3. Now A is less than 1. So now my red graph, my new graph, is flatter. Okay. So that's really, really interesting. I want to show you guys now the effect of Q quickly. So let's have a look at, let's say, I'll make something up. Y is equal to cos of x plus 1. Now that 1 is taking the place of Q, and what I need to see from that is that my graph is shifting vertically up by 1. Now if I don't have all sorts of fancy software, what I would do is I would say, let me draw my normal cos graph. Its minimum value is -1. At the position of rest, it's 0 rather, and then 1. And then I say to myself, but hang on a second, what is happening? This is my normal cos graph. I now need to account for that +1. So what I'm going to do is on all of the labels on my y-axis, I'm going to add 1. So if I go -1 plus 1, I get 0. If I go 0 plus 1, I get 1. If I go 1 plus 1, I get 2. Now this means something interesting. Obviously, I must now draw my x-axis at the 0. I'm going to erase the old x-axis the best I can. And can you guys see my cos graph has jumped up 1? So let's try and do it using slightly more sophisticated methods. So what I'm going to do, my A is 1, all right, so that's fine. Now I'm going to say I'm making my Q 1 as well. And guys, exactly what I predicted with my own rough little sketch, what happened, my graph was translated up by 1 unit. So let's say we have y is equal to cos x minus 3. I don't know if I can go to -3, but let's do -1 at least. -1.5. What has now happened? Have a look at my green graph. Remember, the white graph is your basic cos graph. That's your basic point of reference. What has happened? My graph has moved down by 1.5 units. Right. So guys, I think it's pretty obvious that you can't understand these changes in amplitude and the up and down shifts until you have an idea in your head of what the basic trig graph looks like. Right. We've got a trig graph right at the end of our questions. I hope that we'll get to it, but even if we don't, hopefully you guys have learned something. Where's question 1? I seem to have misplaced question 1. Well, we'll start with question 2. Right. The question says to us, refer to the diagram, and basically all we are given on the diagram is this point P over here, and the point P is in coordinate form. It's in an ordered pair, so I know that x must be -2 and y must be 1. And the first question that they ask me is to determine the value of cos of theta. Now, you should know immediately that cos of theta is adjacent over hypotenuse or x over r. Now, as far as the x is concerned, that's not really a problem. I do know that the x value over there is -2. What I don't know is the hypotenuse. They have named it L here, but they can name it anything they want, really. But I don't know the value of r. And for this, we're very thankful to a Greek guy named Pythagoras, who came up with the theorem of Pythagoras, and this is going to enable us to calculate the value of r, and we're going to go straight ahead and do that. We're going to say x squared plus y squared is equal to r squared. Substituting into the place of x is -2 plus 1 squared is equal to r squared. So guys, remember when you square a minus, it becomes a positive. So this becomes 4, and 1 squared, of course, is 1. And I get that r squared is 5. But it is not r squared that I'm after. I'm looking for r, so I'm going to say, that's fine. R is √5. And I can then go ahead and answer the question. I can say, well, cos of theta is x over r. The x value is -2 over √5. And guys, most of the time, we don't want you to decimalize your answer. That is absolutely perfect. Right. With these sorts of questions, there's often a follow-on question, and that's not a problem. The next question asks us to also determine the value of cosec theta times sine theta. Now, guys, if you're clever and if you were listening to what I was saying earlier, you'll remember that sine and cosec are inverses of each other. What does that mean? Sine is y over r. Cosec is r over y. When you multiply two inverses with each other, your answer is going to be 1. So if you are insightful enough to see that straight away, you'll do that right like that, no problem. Alternatively, you will go r over y multiplied by y over r. You'll substitute in your values, and you will see that it cancels out to be 1. So that was what I would call a pretty straightforward Pythagoras type question. Right. Let's have a look at another one. This is actually question 1, which I missed. So they tell us we have got triangle ABC. Now, guys, I like to have a picture. I just cannot cope without having something to visualize. So let's see. Ooh, unfortunately, my shapes are in black, which is not going to help me much. But that's fine. We'll use my favorite color, pink. So they tell us that we have got triangle ABC and that B is equal to 90 degrees. So let's put that in there. Furthermore, we are told that A is 33 degrees. And then we are told that small a is 47,2 meters. Now, guys, small a would be the side that is opposite from angle A. So that would mean over here, 47,2 meters. And the question that they ask us is to find the length of side B, also known as our hypotenuse. All right. Now, guys, it's often very useful to remember the basic things that you learned in geometry when you were younger. Angles of a triangle add up to 180. So if I wanted, I could have calculated the size of angle C. But in this case, it's not necessary. What I'm going to say to myself is, hang on a minute. I know the size of angle A, and I am going to place myself in position at A. There I am. And I say, well, let me look at what I have and what I need. Across from me, I have 47,2 meters, which is also the opposite side, or y. What do I need? I need the hypotenuse, which is also called r. And then I ask myself the question, which trig ratio uses opposite and hypotenuse, or y over r? And of course, they're all shouting out, I'm sure, Abram, it is sine. So then you write sine of 33 degrees is equal to opposite, which is 47,2, and you can call AC, well, let's just call it AC. So we are looking for side AC. Now, what I want to do is I want to make AC the subject of the equation. Probably the easiest way to do that is by cross multiplication. So going like that, I will get AC sine 33 degrees is equal to 47,2, and AC will then be sine 33 degrees divided by 47,2. And for this, you absolutely are going to need a calculator. So I'm going to clear my maths error from earlier, bring up a fraction, sine 33 divided by, sorry, I've got it the wrong way around, boys and girls. Sure, that was a close shave. Let's just go back to where I cross multiplied. I want AC on its own. So, guys, I'm going to have to divide by the sine 33. That was really not very clever. So AC is 47,2 divided by sine 33. See, even the pros make mistakes. So let's clear that. And at the top, we'll put the 47,2. And that's divided by sine 33. And my answer is 86,6. I would say 86,7 because the other side was given to one decimal place. 86,7. And guys, that makes sense because just remember, your hypotenuse is always your longest side. So if I got a side of like 14, I would have realized that something is up. Right, guys, before we take this break, I want to remind you guys to check out more information on Curio. And you can do that by going to our Facebook page. The code for today is M10. Have I got it right?
Yes, that's correct.
Right, guys, we'll see you right after the break where we'll be doing some more trigonometry.
Well said, Lizelle. Mindset is make sure that you get over Facebook. It's facebook.com/learnextra. We do have instructions for Kira, and the code, once more again, is M10. Also enter for our After Earth competition. But also, before we go to that break, I just want to say a big shout out to all the mindsetters that are on the page saying they're enjoying the show, just like Hope, Tando, Twala, Nompumelelo Mulewa, and also up here we're saying also, mindsetters, mathematics is not really hard if you know your basics and your rule. Also, last shout out to Nomtanda, who's watching all the way from Woodbank. Guys, keep it tuned because we are here to learn more and learn extra. See you after this. Great and mindset. It is still the time where we learn more and learn extra right here on Learn Extra Live with me, Abraham, and Lizelle. Of course, make sure that you get on to your Mixit, because when we're learning here on Learn Extra, we have our phones and also our pens and papers and everything next to us. So on Mixit, make sure that you go there and complete all those assessments that we have. Your code is M10. Make sure that you get all the instructions on our Facebook page as Lizelle continues.
Right, guys, it's important for us that you guys answer the questions on Curio because it also tells us whether we're getting things right. So it's really, really important. Okay, I'm now going to move on to some trig equations, and the trig equations that you do in grade 10 are relatively basic, but there's still a couple of things that you need to know. So in this case, they will say solve for theta, round your answer off to 1 decimal place. Right. Now the first one is very straightforward because on the left-hand side, I've got sine theta. On the right-hand side, I've got a ratio. So if I'm in this position, it's absolutely straightforward. That ratio 0.725 is obviously the ratio of the opposite side over the hypotenuse side. So all I'm going to do now is I'm going to say shift or arc sine of 0.725, and I'm going to press the equals button. And the question did say to round off to 1 decimal place, so the answer to my first one will be 46.5 degrees. Right, so that one was straightforward. But now what's going to start happening in the rest of the questions, it won't be so straightforward to start with, but what you've got to aim for is to get just your sine, cos, or tan on its own on the left-hand side, and everything else must be on the right-hand side. So it's a little bit like organizing an equation. So let's look at what sort of organization we need to do in the second one. So the second one, again, solve for theta, rounding your answer off to 1 decimal place. Right, so we've got 4/5 cos theta. I think that the first thing that I'm going to do is I'm going to remove this 0.172 by taking it to the other side of the equal sign. So I'm going to say 4/5. I'm dealing with cos now. And that is equal to negative 0.172. Now, guys, I don't want that 4/5 on the left-hand side. Remember, beforehand, I had it nice and easy. I had a 1 in front of the sign. So what you can do is either you can divide by 4/5 on both sides, or you can multiply with the reciprocal. It's really the same thing. Look here. If I multiply by 5/4, the 4's cancel and the 5's cancel. But then I also have to multiply by 5/4 on this side. So what I've managed to do now is to get my cos on its own on the left-hand side and the ratio on the right-hand side. And remember, the ratio, because it's cos, will be a ratio of the adjacent over the hypotenuse. Now, you might want to just work the right-hand side out first. It might make some of you feel a little bit more comfortable. So what did we have? 5/4. And we're going to multiply that with, and let's do a bracket, negative 0.172. And the answer that I get is negative 43/200. So maybe write that in. Cos theta is negative 43 over 200. And what you will now notice is that you've managed to manipulate your equation in such a way that it looks exactly the same as the first one. So once again, we can bring up our calculator. And I can go shift or arc cos of negative 43 over 200, close my bracket, equals, and the answer that I get is 102,4 degrees. So basically, guys, question A showed you what you needed to do to all of the other questions so that you could eventually get to the point where you have to get the angle. All right, now in C, we've got another little trick up our sleeve, and that trick is this little bit over here. And this is very important. Whenever you've got something that comes after your sine, cos, and tan, it'll usually be in a bracket. You can't move that over. You can't do anything to it until you've found the angle. So for now, you must just leave it alone. But still, I can work on that 2 in front there. So I can say, right, tan, and remember, whatever's in the bracket must stay there, 3 theta minus 10 degrees is equal to 8,242 over 2, and that's not a hard one to solve. That is 4,121. All right. So, as I said earlier, there's really nothing I can do about that bracket at this point. I'm going to deal with it later. But at least I have ensured that I've got tan on its own on the left-hand side. In other words, there's nothing in front of it and there's nothing after the bracket. So I'm going to get ready and I'm going to bring up my calculator and calculate shift tan of 4,121. So you go shift or arc tan of 4,121 equals. Now I get an answer. I'm going to round it off to 1 decimal place as per the instruction of 76,4. And this is how you're going to roll from here on. You're going to say, now, where before we could say theta is equal to this or theta is equal to that, I'm now going to say 3 theta minus 10 degrees equals, and old age, I've already forgotten, 76,4 equals 76,4 degrees. And now all that remains for me to do is to solve this equation. So I'm going to leave the 3 theta on the left-hand side for now. I'm going to move the negative 10 over, so that's going to make it positive 10. Adding the 10 to 76,4, it's going to be 86,4. And remember, the question says solve for theta. So now I know 3 times a certain angle is 86,4, but I want to know what the angle is. So I'm going to say 86,4 divided by 3. And there's my final answer for theta, 28,8 degrees. 28,8 degrees. Right, so guys, those were 3 little equations. I think before I move on to the trig graph question, which I want to do next, I'm just going to go to Abram and find out how we're doing there. Are people understanding?
So far, so good. You know, I'm just so amazed by the level of understanding that Mindset is are telling me about on the Facebook page. I've got some great comments such as Kiwachele, Kitepile Darling Mokhetsu says, wow, mathematics is fun. I never thought that it would be so fun. Thanks to Learn Extra, smiling forever.
Oh, how wonderful. Well, that is our job, is to try and help you guys. So because we spoke about trig graphs quite a bit earlier, we're now going to have a look at a trig graph question. Now, the question says, sketch on the same system of axes, f of x equal to 2 sine x, and g of x equal to cos of x plus 1. Now, guys, firstly, this question isn't really complete because the sine graph and the cos graph will carry on forever unless I restrict the domain, right? So either I needed to give you guys a number line that finished at 360, or I needed to say something like 4x an element of 0 to 360 degrees, right? So this, what we give you, the x is an element of 0 to 360 degrees, that's the domain, okay? In this case, our domain and our period is going to be the same, but if I ask you to sketch the graph up to 720 degrees, even if you draw up to 720 degrees, in other words, you fit in two graphs, your period is still 360 degrees, your domain is whatever we tell you to sketch the graph for. Okay. So very, very important is I need to have an idea in my head of what I'm working with. So if I look at f of x equal to 2 sine x, I see that that 2, which comes in front of the sine, is the a, and the a affects the amplitude. So unlike the ordinary sine graph that has a maximum value of 1 and a minimum value of -1, this graph is going to have an amplitude of 2. So that's where I'm going to start. And I'm going to put in all my relevant points, 0, 90 degrees. I'm trying to keep them evenly spaced, 180 degrees, 270 degrees, not that evenly spaced in the end, and finally 360. So I'm going to put on my y-axis 1, and I'm going to put on 2, because I know that it's going to go all the way up to 2, and then on my x-axis -1. Sorry, on my negative y-axis rather, and -2. Okay, now this is a sine graph. I know that it reaches its maximum value over there at 90 degrees. Guys, try and keep it nice and curved. I know it's not always easy. And it's going to go down there to 180. It's going to go down to its minimum value over there at 270. And up to 360. And it's never a bad idea just to indicate with a little dotted line that that is on par with 2, and this is on par with -2. Now, I know my graph's not beautifully symmetric, but that's a pretty good effort. All right. Now I need to talk about my cos graph. The cos graph is y is equal to cos x plus 1. Now, the cos graph's amplitude is still 1 because the value in front of the cos is 1. However, what has happened to the cos graph is that it has been vertically shifted up by 1 unit. So I want you guys to visualize my cos graph that has shifted up 1 unit. I'm going to go back to these guys over here, and I'm going to say y is equal to cos x plus 1. So guys, this is what I'm looking at. What's going to happen is my cos graph is going to start at 2. It's going to gradually go down. It's going to reach its minimum value over there at 180, and it's going to go up to 2 again. But it's important that the amplitude of the graph is not 2. The position of rest is still in the middle here, and the maximum displacement from the position of rest is still only 1 unit. So let me quickly draw my cos graph. Now, guys, this is a little bit easier said than done, especially, okay, let's just try a different color at least. It's going to go gradually down there to 180, and all the way back up to 2 over there. Right, guys, that definitely isn't the prettiest graph, but we have shown you guys exactly what it looks like with the electronic software. So in today's lesson, we've done some Pythagoras questions, we've solved triangles, we've done equations, we've looked at trig graphs. So basically, a little highlights package of everything that you need to know in trig. But guys, take your textbook, work through all of those old examples again. You'll never be sorry, especially when you get to grade 11 trig. Abram, over to you.
Thank you so much, Lizelle. Mindsetters, thank you for taking your time as grade 10s to watch our show and also to be on our Facebook page, also helping one another. We just want to say big ups to you, and you know what? You rock. Mindsetters rock. So Mindsetters, this is the end, unfortunately, for grade 10s. We'll see you some other time. To all those that are writing their exams, good luck to you guys, and always study hard and smart at the same time. Be prepared, know your stuff, because when you get to the exam room, there's no Lizelle. You're not going to see any of us. It's just going to be you and that paper. So make sure that you're up and ready for it. Always know your basics, because when it comes to maths, if you don't know your basics, you're going to go wrong. So make sure that you don't cram, you just know your stuff. Thank you very much. From me, Abraham. Bye.